To truly understand the cloud native journey and its importance, we need to first look back at what the world of infrastructure and services was. So let's go through and understand some history lessons or cloud journey. And that's not it, because everything comes with some pros and cons. So we need to understand the challenges of the cloud so that when we talk to the customer, we know what we're talking about and how we can fix it. So if we talk about back in the early days of the internet, the overall web application infrastructure was hosted on physical servers that needed to be planned, purchased, and prepared before applications could be served from them. Don't forget the physical location where you're going to put it. Maintenance of that physical location, electricity, coolant, team. IT teams had to physically buy the servers and set them up on premises, install relevant server operating systems, prepare the environments, and then deploy applications on top of them. There were many problems with this approach, and now, since a lot of us are born in the cloud, because they don't know this situation actually faced by the people, so they already know the problem with this approach. For example, you would have underutilized servers. It was difficult to run multiple applications, and setup and maintenance costs were high. Before your application is up and running, you need to spend a lot of money for the physical locations, servers, and a lot of maintenance things that we talked about. So that was the first point. It was physical servers at the beginning of the internet. And then virtualization came. Virtualization was developed to allow more efficient utilization of physical servers. It was virtualizing the hardware. Virtualization creates an abstraction layer over physical hardware that allows underlying resources such as processors, memory, and storage to be divided and shared in form of virtual machines. Virtualization solved many problems with resource utilization and multi-tenancy, but you'll still needed to own the hardware to deploy your application, and you still needed to maintain all the overhead of running your data center. This gave rise to the need to run infrastructure as a service. Yes, we have entered the cloud now. So there was some issue with the physical servers, then virtualization fixed those issues. There was some things with the virtualization, then cloud IaaS came into the picture, where the servers are owned by third parties that are responsible for your applications underlying infrastructure. This was the beginning of the cloud computing era, and it allowed companies to focus on their applications and underlying environments without worrying about the hardware, because it doesn't belong to them, it belongs to the cloud providers. IaaS was followed by what? If you're guessing platform as a service, then of course you're right. PaaS. IaaS was followed by PaaS, which focused on reducing the toil further by separating the underlying software environment and runtime. Remember the shared model that we went through? This is what it was meant. This meant developers only had to focus on writing their applications and defining the dependencies, and the service platform would be completely responsible for hosting, running, managing, and exposing the applications. And then, of course, PaaS led the way to fully managed cloud services with the SaaS, software as service, or we could also say on-demand software, which provides consumers with the application as a service. As a cloud computing gained in popularity, so did the idea of having cloud native technologies. Last few videos we talked about cloud native application, cloud native. Now we have arrived here from our cloud journey, cloud native technology that would use the cloud more efficiently while harnessing the full potential of cloud infrastructure and its various offerings. This gave rise to the development of cloud native infrastructure and cloud native application development. Cloud native infrastructure creates an abstraction on the cloud provider's underlying infrastructure and exposes the infrastructure with APIs. This infrastructure management philosophy makes it very easy to scale and reduce underlying complexity, which indirectly improves availability, resiliency, and maintainability. Similarly, cloud-native applications fortify the bridge between application and infrastructure by incorporating supporting features such as health checks, telemetry and metrics, resiliency, a microservice environment, and self-healing. So that's how we can harvest the benefits of the cloud if we are thinking cloud native. If we are moving from physical to virtual to cloud IaaS, now we are not actually harnessing the power of cloud. We need to think cloud native. We need to apply the mind which thinks cloud first for the applications, of course. But as I said, everything is not hunky-dory. Everything is not hunky-dory from the perspective of when you have something, you got to lose something. So what are we losing here? There must be some challenges. So let's see what are the challenges here. Oh my God, it's a full web of challenges. But don't worry, it seems like pretty normal. Once you've been through the journey, then you can easily relate. And of course, when your customer will talk about them, you have the answers. Public cloud providers have become a dominant enterprise solution for a lot of growing industry needs and business requirements. They give you advantage such as higher availability, scalability, along with the flexibility to design your application in a way that utilizes cloud services. When cloud solutions were first introduced, numerous challenges, including security, effective cost management, compliance, and performance, concerned potential customers. Those early challenges are now a thing of the past for the majority of the cloud consumers, as they have been overcome with advances in both cloud provider technologies and the way enterprises deploy solutions on the cloud. Even though we have come a long way, this does not mean the cloud is perfect. So your guess is correct. It's time to face the challenges. The very first is there are plenty of cloud providers out there with an extensive array of services to choose from. This means you need to hire expert architects and engineering teams who know how to operate the services and use them according to your business use case. Not only is hiring these engineers difficult, but finding engineers who are experts in a specific field requires a significant time and money investment. A huge number of new cloud services are being released by cloud providers like Amazon, Microsoft, and Google. There are updates every other day. These results in a greater need to train engineers in these new services and a greater need to maintain these services in the future as the application grows. Often, the level of investment in these services also indirectly causes vendor lock-in, resulting in a spiral of future constraints in application design. As we have moved into the cloud era, we have also lifted and shifted our application stacks from various generations of infrastructure solutions, ranging from virtual machines to containers to serverless technologies. This migration of applications require a significant amount of effort to understand the underlying technologies and support them in the future. These rapidly growing technologies, combined with accelerated migration of workloads to the cloud, have given rise to operational complexity and an ever growing list of factors to look out for. New eras of technology and culture change have also rapidly evolved the enterprise architecture. For instance, with the advent of the DevOps culture, a new application that once took weeks or months to develop can now be rolled out in a couple of minutes. More advanced areas such as data science and machine learning have also come into the picture, increasing business needs and overall engineering maturity. So, despite the power of cloud computing, business had to wade through numerous complexity. Eventually, it became clear that businesses wanted to have the speed, scale, and margin of the cloud, but none of the overhead. To accomplish this, it was necessary to embrace the cloud native approach of application building, which would help companies take full advantage of the cloud. Well, with this, I hope the cloud native series that we have started is pretty much clear what it is, why it is, and how it's helping us. Well, thank you for watching, and you guys